Welcome by another episode of the Train the Trainer podcast. We're trying to bridge the gap between science and practice, and mostly for first responders like police, military, and emergency medicine. And today I have a conversation with Karin Roelofs. She's a professor of experimental psychopathology at the Behavioural Science Institute and chair of the Affective Neuroscience group at Donders Institute for Brain Cognition and Behaviour. And this is all in the Radboud University Nijmegen in the Netherlands. So Karin, welcome. And we will, yes, and I follow your work for a long time about the freezing and about the game you developed to help police officers to deal with acute stress and so on. So and we decided to give a short overview in English for our international colleagues. So I put the pressure on you.
Yeah, what I can do is explain a little bit about what we do and what is actually for the police the problem that we are facing. So,
great.
Well, first of all, really nice to be here. So police officers are often, of course, exposed to stressful situations that elicit fight and flight reactions and increase our heart rates. And yet they have to remain calm and make rational decisions. And that is, of course, a paradox. So how can we resolve this paradox? And that is where freezing comes in. So freezing is a state in which the heart rate is low, we're immobile, we're not moving. And it's a state in which that is optimally geared for rapid decision-making. We're hyper alert and we have increased perception. And this low heart rate during freezing, also called bradycardia, makes that freezing as a state that is optimal for decision-making and action preparation. And over the past decades, we systematically showed that low heart rate during freezing is not only relevant for acute action decisions under threat, but also for long-term resilience. Okay. And therefore, we have developed a game just to bring our bodies in a state of freezing.
Can I just go a little bit backwards, because what triggered me in this, and I heard you talk about it many times, but for me and for many of us, freezing is a very bad thing. And now you are saying that it is great for decision making. So I'm a little bit freezing right now.
Exactly. Yeah. So freezing is sometimes used for sometimes people use the word freezing for police officers when they no longer perform. But that is a little bit confusing, because if you look at the animal and human literature, what freezing is actually when we are exposed to a threat cue, the first thing that often happens is that the heart rate goes down and we're immobile. We're hyper alert for additional cues that may prime subsequent fight or flight reactions. And this is actually a state where we have better signal to noise in the brain. We have upregulated perception, we're hyper alert, and we have a lot of activity in the sympathetic autonomic nervous system. Our autonomic nervous system has two branches, sympathetic and parasympathetic. Sympathetic makes, we have noradrenaline and heart rate goes up, and we start to sweat a little bit. There goes a lot of blood goes to the periphery, and we're completely ready to go. The cool thing about freezing is that we have concurrent sympathetic activity, so there's a lot of sympathetic upregulation, but at the same time, there is parasympathetic upregulation. So both branches of our autonomic nervous system are active, and the parasympathetic branch of the autonomic nervous system is dominant. And parasympathetic dominance leads to a brake on the motor system. So, and that means we're completely ready to go. We're completely, the pupils are large, we are alert, there's a lot of muscle activation, co-contraction, but there's dominance in the parasympathetic autonomic nervous system. And that makes that we have a net heart rate deceleration. So although it's upregulated by the sympathetic, the parasympathetic is dominant. So there's a heart rate deceleration, and we are temporarily immobile. And you have to think of a car race. Imagine you are in a car race or you are in traffic. You're sitting in your car and the traffic light is on red, but you have to go off as soon as you can. What you do is you put on both the gas and the brake. And to get off quickly, the only thing you have to do is release the brake and off you go. And that is actually the analogy of threat anticipatory freezing. It's a unique state and it's very important for decision making. And over the past years, we found that it upregulates perception. If you freeze more deeply, if the heart rate deceleration is more strong, and if you are a little bit more immobile in this state, you're actually better in decision making, you're faster in the subsequent response. So it's really optimal to freeze. So this is actually what threat anticipatory freezing is. Now, then once you've made the decision, the body prepares for action and fight or flight reactions can be generated. Sometimes that is unsuccessful and that all doesn't work and we're overwhelmed. And then we enter in a fright state. So we have freeze, fight, flight, and fright if it all doesn't work out. And what the police is calling freeze sometimes is actually the fright state. You're overwhelmed, you're in panic. And it's not that during, and they can still be moving, you don't have this low heart rate, but there's bad performance. So
somebody can be in a fright state, so to speak, while when I'm observing him or her, she or he is still moving or doing some.
Yes.
Yeah.
We have observed police officers, for example, during a big disaster that happened, and they should be performing well, but they were actually handing gloves to people or just started to do crazy things. And that can happen to people who are overwhelmed by stress. You could also call this choking under pressure.
Yeah.
And actually to not confuse the world too much and to stay a little bit attuned to the literature, it would be good to not call that freeze, but yeah.
Okay, yes.
Because they're moving,
but
it's not controlled fashion. It's more panic-like, choking under pressure, or if you like pressure, or if you like fright.
Yes.
Yeah. So that is how I would call that.
Yeah. And then the question is, what did you do with that knowledge? That you went further to develop interventions?
Yeah, that is a nice question. So we did two things. Of course, we're scientists. So we first wanted to investigate if freezing is indeed important, if this state of heart rate deceleration in anticipation of threat is predictive for long-term resilience, because we know it's important for acute decision-making under stress. But first, we also wanted to know, is it also important for long-term stress resilience? So first we did an investigation into that. In 2012, the NWO gave us $1.5 million, and we set up a very large longitudinal study. We followed 400 police officers, and we've now followed them for 8 years.
Wow.
Invited them from all over the country to Nijmegen, to the Donders Institute, where we stressed them for a full day. We put them in the scanner, we stressed them, all went up, and we measured the acute stress reactions. And we did this when they had just been selected at the police academy. So they were still fresh and happy and healthy and just selected. So it was a very, you could say, what could be a resilient group, very young people eager to go into the police academy, no complaints. Then in the Netherlands, as part of your training, you're exposed, you have to serve in the emergency aid for 3 times, and you're exposed to many potentially traumatic events. And we knew from previous research that 30% of them can develop stress symptoms. Not full-blown PTSD, but some stress symptoms. And we wanted to know whether we could predict who is vulnerable to developing stress symptoms and who is not. What makes people vulnerable? And for that, we followed them, and then we tested them again, we stressed them again, and we're still following up these police officers. So it was a huge project. And one of the most important findings was that this heart rate deceleration and control over these automatic defense reactions, fight-flight reactions, that is actually one of the most important predictors of whether you will be resilient against the adverse effects of the trauma. So those who show nice heart rate deceleration, they are also ones that do better in the long term. So not only acute stress reactions, but also in the long run.
Is there a physiological explanation for this? Why? I mean, I think about, and I'm a complete amateur, but I think about the nervous vagus or something, or what happens? What happens that they become more resilient? Why is that? Do you know that?
Yeah, the why question is always difficult, huh? So we can only look at correlation, but yes, we do have a hypothesis about the mechanisms. So basically what we observe is a couple of things, and the nervous vagus is important, of course, for this heart rate deceleration. So there's a few things that are happening. Under acute stress, you could end up in immediate fight or flight. And then there's high heart rate.
Mm-hmm.
And as I already mentioned, it's actually more beneficial to first have this heart rate deceleration. That means that there is more variability in the heart rate, and that makes us more flexible and better able to react in a flexible fashion.
Yeah.
The nervous vagus plays a role there. And we also know that prefrontal cortex plays a role. In the scanner, we see nicely that those who recruit their prefrontal cortex more when they have to exert control, that they also do better. So yes, we do have a neurophysiological explanation. And then the next question is, of course, can you train this?
Yes.
And then the NWO, so the Dutch Research Foundation, said, well, maybe if you have a nice plan on how to train this, we will fund this. And then in 2017, we got funding to develop a VR game that is based on biofeedback, and where we train people to get into that state under acute stress. So what do? We have this VR game, and people have to make rapid decisions under stress. It's actually a zombie shooter game. And the nice thing about VR is that we can ramp up the stress, something that we can't do in a classroom. And we force the police officers to bring their heart rate in an optimal state. How do we do that? Well, we have a closed loop system that automatically transfers the heart rate variability into the visuals of the game. That means that when your heart rate variability is not good, it gets dark and it gets really difficult to perform. And then if you bring your heart rate variability again in a good zone, it gets light again and you can perform the game. So in a very playful way, we force police officers to become aware of their psychophysiological state and to control it.
Yes.
And that is actually, and that worked nicely. There were a couple of critical elements in this game that we discovered that are important, but in the end it worked, and we could find transfer to the real world, and that is the most important thing.
Yes. So about transfer, because I heard you talk last week or 2 weeks ago with the military performance psychology group. And then you talked about how realistic the game should be, and it triggered me because in police training there is and also in emergency medicine there's always a debate about high versus low fidelity scenario training, and but you talked about maybe in basic training it doesn't have to be that realistic. Can you explore that a little bit?
Oh, yes. Yeah, I think that's really an interesting topic. Many people think that a VR game has to be completely realistic and that the environment has to be realistic. But what has to be, and that it has to do with ecological validity, you could say. Yeah? You have to train in an ecological valid situation to be able to get transfer. There's a few things that are important here. The context that has to be ecologically valid is more the psychophysiological state that you're in, the fact that you have to be in an action mode, and the fact that you have to be under stress. That is important. That is what makes it ecologically valid. But that is not in the visuals of the game or in the scenario. In fact, if you try to make the VR environment very realistic, then people start to compare it to their real world. And they think, no, my street is slightly different. Oh, this avatar looks a little bit different than my colleague. Or they start to pay attention to the differences between the game, because it's never perfect, and the real world. And so it's way more important to think about, what do you want to mimic? Do you want to mimic the visuals? Or do you want to mimic the state that somebody is in? And we found out that it is way more important to make sure that the body is in the state that you want it to be in the real world. And that is active action, decision-making under stress. And we ended up actually with a scenario that is very unrealistic. Zombies in a parking garage. First, because you don't want police officers to train them to shoot real people. But it has to be possible. And what is important that we could train a couple of important skills that police have to do. So one is, of course, the physiological awareness, but also often they have to make go, no-go decisions under threat.
Yeah.
And we made them, they had to perform go, no-go decisions. Then sometimes they had to make a shift. All of a sudden they get a report like, now you have to pay attention to these type of people, which often happens to police officers. They think they have to do this, but then all of a sudden they have to do something else. So that's a set shifting. We have that in the game too. Plus, if you're stressed, you get a narrowing of attention. And during the game, you have to make sure that you keep looking around. So we made sure that they had to do police relevant stuff, but then in a context that is as unrealistic as possible, actually, to avoid to compare.
And what tools? Because if I understand you correctly, if they could self-regulate their stress or their RHV, then the vision became broader, so that they could see better. But what kind of skills did they use? Because we have since 10 years or something, we have within the police the mental strength program with all those tools from breathing, goal setting, and so on. What did you do with that?
So we did 2 studies. One where we trained them to pay attention to breathing, because we know if you pay a lot of attention to exhalation, your heart rate variability goes up and the heart rate goes down. And that's exactly what we want. And that is effective. And the second thing that we tried is to train them directly on heart rate variability. So not on the breathing performance, but on the heart rate variability directly. And that was very effective. Both were effective. But now what the game now has is actually we have a real-time estimate of the heart rate variability, and we train them to be in the right.
But how can they do that? Do they see their RHV, and what can they do to make it optimal?
So we leave the strategy to themselves. It's more effective if it's up to them on how to do it. But many of them use breathing. They use breathing skills. But the way they want to use it, that is very personalized. So for some people, it really works to pay attention to exhalation. For some, it pays attention to think about slow breathing. So the way they want to do that is fine. What we feedback in the game is the heart rate variability. And it doesn't matter how they achieve the goal, but they have to achieve the goal. Otherwise, it's too dark and they make many errors and they are being shot.
Okay. So then I have the experience in the game. So I'm doing my strategies, and hopefully I have some good results. My heart rate variability goes up, and my vision becomes broader. But how do I remember? Yeah, I think remember. Yeah, how do I get access to these tools when I'm, for example, on the streets? What happens there? I have to. No, now I'm talking myself. This question for you. I can only guess, but
yeah, how can you give a reminder? That is something we are investigating now. So we again got a follow-up grant, and we're now investigating, or we're starting to investigate, because the cool thing is, by the way, that if we train people with this game, they show better control over heart rate variability also when the biofeedback is gone. Again, so we see transfer to when we don't give biofeedback. Plus, we see transfer in a real world shooting situation. So to perform, so it really transfers, and that's the good news. That's why CZ and other people were interested in actually implementing the game. And one thing that we will start to investigate now is if we could give them a trigger, a reminder. So you do the game, and perhaps you could say, okay, now that we have that, then they have trained them, and there is a visual cue that is linked to the game, namely the whole interface. And the thing that we are investigating now is whether we could actually, we have a nice way to monitor their heart rate in real life. And if it gets a little bit too high, then we give them a small reminder. Or with police officers, right before they have to go into a situation that is potentially threatening, we give them a brief reminder. But it has to be really brief, because police officers don't have the time in a stressful situation to do a breathing exercise. It's unrealistic. They're not interested in looking at their watch. And it has to be a very brief reminder, and that's what we're working on and investigating now.
And do you think that there is some literature about this, about habit formation from America? Michael Lauria, he's a former military and now emergency medicine doctor, and he talks about stress control strategies. And his proposal was that make it a habit, like a habit is, for example, if you are on the shooting range, you shoot and you make a brief scan, and if you do it many times, maybe it becomes a habit. Is that also a possibility to? Yeah,
exactly. I think that is exactly what you need. It's just that you have to optimize that training situation first, and that's why we have it gamified, because they have to like it. If you tell police officers breathe out, that is too, and that counts for everyone. That's a little bit too esoteric, and you don't understand. That's why we have a game that is nice, where they can really experience why you have to learn this. It has to be a little bit fun, because you don't want to sit in a classroom and just do breathing exercise. It just doesn't work, by the way. So once you have a good training situation, and the nice thing was that most of the people really liked it, and it got into competition, and we were actually approached by people like, oh, can I play it too, because it's so cool. Once you have a positive connotation around this training, then these triggers work. Then you can start to habituate it. So you need both. You need a nice experience, a nice effective training experience that can show transfer and that really engages people, and that is in a stressful action situation. It has to be during action, otherwise it doesn't transfer to the real action world. And then those triggers work, these reminders. Then you can start to habituate it.
So we have 5 minutes left. Is in this? Is there anything? Because last time you spoke about a kind of progression in your training, so to make sure the transfer is there. If I remember correctly, well, just exactly what you said, like this. There is no transfer from rest to a stress situation. So you have to develop the skills in a stressful situation, and preferably, I think, with biofeedback. When I talk with Judith Anderson, she also emphasized this, the importance of biofeedback. But the reality of police training is that they don't have always the biofeedback stuff right over there. So are there any?
Yeah.
What is your recommendation?
Well, the way in the mentale krachttraining in Holland, which is part of the police curriculum at the police academy, the way biofeedback is implemented now is that they're sitting in a classroom situation and they're being trained. And that unfortunately doesn't transfer to the real world. So what we do now is the police academy is reprogramming our game on their system, so that all the police officers have access to it and that they can actually work with this biofeedback scale where there's stress, there's an action context, plus it's real time.
Yeah.
And that is a combination that, we usually don't have. I think this is one of the first trainings where you have all of these elements in there. And to make it accessible, we are programming it now on Quest, so that the whole Dutch National Police has access to it. And the idea is that all police officers will be trained with it. Yeah.
And so for me, the low hanging fruit, so to speak, is for me as a trainer that you should train those skills in a stressful situation, of course, matching the qualities of the participants. And then to habituate I think it's important to record. In my training, I always try to I follow the 3 R's from recognizing, regulation, reflection.
Yes.
So I also in our experience, the awareness of, I'm becoming a little bit too excited. That's a good thing in itself, I think.
Yeah. So what my recommendation would be is train first.
Yeah.
Then yearly boost sessions. That is what we are discussing with the police now, is to during the yearly boost that they get also for shooting, have just play the game again, so that it's boosted. And for every police officer, you have a personalized cue, and that could be a word, or that could be a picture that they get in their mind, and that you habituate to real life situations. So that in real life, it is not demanding. You cannot ask them to do complicated stuff, but if you give them just one keyword, but that is personal, what works for them. And that is something that people can do. The ideal world.
Yeah, and it's great because I recently talked to Christian Iterbol. He's a former sniper team leader from the Norwegian army, and he is currently defending his PhD on research into implementing mental strength training in sniper corps, and it was exactly what they found, that there is a large individual preference. So they in coping tools and
exactly. Yeah. That's why we no longer train directly on the breathing, but we train on the HRV. Yeah. And it's up to them how to achieve it.
Okay.
You really have to make it personalized.
Yeah, great.
And that really helps. And you're completely right. Snipers do exactly the same thing. They bring their body in a state of freezing.
Yeah.
That is really the state of freezing, because there's immobility, there's hyperalertness, and their heart rate is very low. Yeah. They have upregulated sensory processing and decision making. It's exactly what we're aiming for.
Yeah.
But then for snipers, they bring themselves in the situation voluntarily. Whereas during a threat-induced freezing, you get in there automatically, but you have to stay there a little bit longer and not immediately move to the fight-flight.
Yeah, wow.
And that is actually exactly what we train with this tool.
Great. Because of the time, I will send you another link in 1 minute, okay?
Okay.
Thank you so much.
Yep.